We mentioned previously that when you're doing backups on a distributed system, things can get complicated. And the distributed version of a disk, if you like, is a striped RAID set. So just briefly to remind people what's going on here, you have a piece of data and you're going to write that to the most simple scenario. Not one that we recommend for production, but it is easy for illustrative purposes. This is a RAID 0 stripe across two disks. This piece of data gets broken up into two pieces that's written together in a single stripe across the two disks. Now, most snapshotting technologies work on a disk by disk basis. So let's say that when you initiate your snapshot, this particular write hasn't quite made it yet, but this one has. So what you've got is basically half a stripe that's been made, and you take a snapshot here, and you take a snapshot here, and when you try to combine the two afterwards, what you end up with is an inconsistent vision of what this stripe set should actually look like. And you can imagine that the more disks you add into this equation, the more likely this is to potentially happen. RAID 1 does not have this issue, but anything with a stripe in it, RAID 0, RAID 10, is going to encounter this problem. So snapshotting with RAID in the mix can be problematic. So having RAID and trying to do a snapshot-based backup introduces problems and complexity, but it's not impossible. There are ways around the difficulties presented. One of the more common ones is to run LVM on top of the RAID. So in other words, the RAID is as far as the LVM is concerned anyway, everything then is a single volume. That's what you're snapshotting, and it's the LVM software running on the top of that takes care of that snapshotting capability. Another option is to go back to the previous implementation when we were just using a file-based copy and to essentially freeze the data. There's a couple of different ways to do that. Obviously there's fsync lock on the database or shut it down. Some file systems will give you the capability to actually freeze the file system. XFS does this with the XFS freeze command, for example, one of our supported and recommended file systems. What you'll generally see is when you're looking up this kind of strategy, you'll see these two recommended together. And the reason for that is that if you do an XFS freeze on a running database, you're essentially making that file system read-only, which is very similar to running out disk space and other things. When the database tries to then write to disk, it's going to get errors, it's going to have problems, it might start blocking, waiting for those writes to actually work. Whereas if you do an fsync and lock, you've already flushed the disk, you're not going to have any more writes, or if you shut this server down, it obviously won't be writing any further to its databases. So the reason why you might see this sort of thing together, because if you've already done this, seems somewhat redundant. Perhaps there's other data on there that you want to get into that snapshot that is not covered by doing an fsync and lock in MongoDB or a shutdown on the database. Perhaps there's some other data that you wish to grab as part of your point-in-time snapshot. In that case, you do your XFS freeze to guarantee that that's not changing as well. Essentially, when you get to this point, you're back to just using snapshotting for convenience. You're not using any of the point-in-time capabilities, and you're essentially taking a hit in terms of when you're actually able to write to the database, write to your data files.